Have you ever just been listening to a song and wondered, how is this even possible? How can a simple object like a violin or a drum create something that feels so powerful? Well, it turns out it's not magic, it's pure science. It's all about an invisible force that connects an instrument to your brain. So let's follow that invisible force and see where it takes us. So here's what we're going to cover. We're going to start with the secret ingredient behind all music, energy. Then we'll look at how instruments actually turn movement into sound. After that, we'll follow that sound on its incredible journey into your ear, figure out how to decode its language of loud and soft, high and low, and finally, we'll talk about that fine line where beautiful sound can actually become harmful noise. All right, so let's get right into the big secret. At its most basic level, every single note you've ever heard isn't really a thing, it's energy. It's this invisible force, a wave of motion that travels from a source right through the air and directly into your ears. And that really gets to the heart of the matter, doesn't it? How does a physical thing, wood, metal, a string, create this non-physical, powerful experience we call music? Well, the answer is all in this amazing transformation, turning the energy of simple movement into the energy of sound. And that new form of energy has a name, sound energy. It's created at the exact moment an object starts to vibrate, to just move back and forth super, super quickly. That vibration, that is the key that unlocks absolutely everything. It is the birth of every sound we hear. So how do instruments actually take advantage of this? How do they take a simple physical action and turn it into a beautiful controlled sound? Well, when you break it down, it's actually a pretty simple three-step process. Think about any musical instrument as a little energy converting machine. It takes an input, that's the movement energy from your fingers plucking a guitar string. The system, the guitar itself, takes that energy and processes it. And the output? That's what we hear, pure sound energy. It's this beautiful, simple flow. You move something, it vibrates, and we hear it. And it really does all come back to that one crucial action, vibration. I mean, whether you hit a drum, blow into a trumpet, or drag a bow across a violin string, what you're really doing is forcing a part of that instrument to vibrate. And that vibration starts to shake up the air all around it, setting off a chain reaction that we're going to follow in just a second. And what's so cool is how many different ways humans have figured out to create that vibration. You can hit something, shake it, or scrape it. That's percussion. You can pluck it or rub it. Those are your string instruments. Or you can blow air right through a tube, making the air itself vibrate. 3 totally different methods, all aiming for the exact same goal. Create a vibration, create a sound. Okay, so the instrument has vibrated. It sent that sound energy out into the world. But how does that invisible energy become a sound inside your head? Well, this next part of the journey is just an amazing piece of biological engineering. And this quote is the perfect way to picture how that journey begins. Those vibrations create waves in the air, kind of pushing the particles around the instrument. It's exactly like dropping a pebble into a still pond. The sound waves spread out in precisely the same way, in all directions, getting a little weaker the farther they go. And when those waves finally reach you, your ear acts like a perfect receiver. First, your outer ear is shaped to funnel the wave in, causing your eardrum to start vibrating in perfect sync. That vibration then gets amplified by 3 of the tiniest bones in your entire body, and they pass it along to a tiny spiral-shaped chamber called the cochlea. Now, this is where the real magic happens. Inside the cochlea, that physical vibration gets converted into a pure electrical signal, which a nerve then shoots straight to your brain. It's only then, after that whole incredible chain reaction, that you actually hear the note. It's just an amazing process. Okay, so we know how sound is made and how we hear it. Now we can finally start to decode its language. Why do some sounds boom while others just whisper? And why does a tiny flute sound so different from a giant tuba? Well, it all comes down to the shape and the speed of those sound waves. Let's start with volume. This one's actually really simple. More energy equals a louder sound. When you shout, you are putting a ton of physical energy into your voice, which creates big, powerful sound waves. When you whisper, you're using just a tiny bit of energy, creating small, gentle waves. Loud, soft, it's all about how much energy you put in at the start. Pitch, on the other hand, is all about speed. A high-pitched sound, like a mosquito buzzing by your ear, is caused by incredibly fast vibrations. And a low-pitched sound, like a big dog's growl, comes from much, much slower vibrations. This is exactly why smaller instruments that can vibrate really quickly, like a piccolo, create high notes, while larger, looser instruments that vibrate slowly, like a big tuba, create those deep, low notes. Now, sound gives us so much: music, language, it even warns us of danger. But there is a point where sound stops being helpful and actually starts being harmful. And understanding this boundary is a really critical part of the science of sound. We call this noise pollution. And it's basically any sound that's so loud or that lasts for so long that it begins to physically damage all those delicate little structures inside our ears that we just talked about. So to really understand the danger, we need a scale. We measure sound in something called decibels, or just dB. And way down at the bottom, we have a quiet whisper, which clocks in at around 30 decibels. Totally and completely safe. Now let's jump way, way up the scale to something like an ambulance siren right next to you. That can hit 120 decibels or even more. That is a massive difference, and sounds at this level can cause immediate pain and even damage. But the real danger zone for most of us is right here, at 85 decibels. This is the magic number, the crucial threshold. Any sound louder than this, if you're exposed to it for a long enough time, can start to cause permanent hearing loss. And this isn't about that immediate pain. It's about slow, gradual damage that adds up over time. So the next time you put in your headphones to listen to your favorite song, I want you to remember that whole incredible journey that sound takes just to reach your brain. And then just ask yourself a really simple question. Am I enjoying the music, or am I creating noise pollution right inside my own head?